Hello, good morning, students. Let us look into some of the reactions of ethers, and which involves a benzene ring. So this is the benzene ring, and ether is a compound which has got a R O R dash in it. So this is called as an ether, and here this particular aromatic ether is called as anisole C6H5. This benzene ring stands for the C6H5 group, and OCH3 attached to it is called as anisole. Now let's look at two of the equations, which is called as halogenation and nitration reactions. Now, in halogenation of anisole, in the presence of bromine in ethanoic acid, you will find that the bromine gets attached itself to the aromatic ring either in the 1,2 position or 1,4 position. The 1,2 position is called as the ortho position. The 1,4 position is called as the para position, and we will find that both in halogenation and in nitration, the para position product which is being formed is in major quantity. The minor product, the ortho position, it's also being formed. Ortho product is also formed, but it is only in very minor percentage. So the major percentage of the compound that is being formed by halogenation and nitration is a para position. So here the bromine in halogenation, when bromine is being used along with ethanoic acid, the bromine gets attached in the para position and forming the para bromoanisole. This is called as the para position. Para bromine group is attached to anisole, so it is called as para bromoanisole. Now what happens on nitration? When you take concentrated sulfuric acid and nitric acid and treat it with anisole, you will find this releases a NO2 group. So this NO2 nitro group gets attached itself to the benzene ring either in the ortho position or in the para position. Both the products are being formed, but the para position product becomes the major product. This is the ortho 1,2 position is called as a nitro group, gets attached in the second position here, and it forms the minor product. So how do we name this? Only this compound is called as anisole. This is the ortho position, so I call it as ortho nitro anisole. What shall we call this one as? This is anisole, this is just anisole, and this diagonally opposite the group attached is the para position, so I call it as para nitro anisole. This becomes a major product. Let's look at a very important reaction of anisole, which is called as Friedel-Crafts reaction. You should understand that a Friedel-Crafts reaction is a reaction of benzene with alkyl halide CH3Cl or CH3CH2Cl, an alkyl group with a chlorine group or a halogen group. It's called as Friedel-Crafts alkylation. And when you treat a benzene ring or a benzene compound with CH3COCl, it's called Friedel-Crafts alkylation, acylation. This is called alkylation, this is called acylation. This happens in the presence of anhydrous AlCl3, which acts as a catalyst. Okay, so Friedel-Crafts reaction means always remember there should be a benzene group or a compound containing a benzene ring. Here it is anisole, which contains a benzene ring here. When it reacts with alkyl halide or acyl chloride, that is CH3COOH, is called as acetic acid. So from acetic acid the OH group is being removed and Cl group gets attached here. So this is called acylation. This happens in the presence of anhydrous AlCl3 as a catalyst. So what is being formed there? we will always find in a Friedel-Crafts reaction there is an addition of an alkyl group or an acyl group, that is a carbon atom, gets attached itself to the benzene ring. That is what you have to remember in any Friedel-Crafts reaction. So Friedel-Crafts reaction will always, you will have to remember that there will be a benzene ring reacting with a acyl chloride or an alkyl chloride. Right. So what is a compound that is being formed here? This is anisole. Now to this anisole, in the ortho position or in the para position, CH3 from CH3Cl gets attached here. How does that take place? From the benzene ring, one of the hydrogen goes away with chlorine. So the remaining alkyl group gets attached in that particular position. So if it is from the ortho position, hydrogen is removed, you will get ortho, what is this called as? Yes, to name this compound, let's take only this part of it. This part of it, C6H5CH3, is called as toluene. C6H5CH3 is called as toluene. So OCH3 group is called as a methoxy group. So this methoxy group along with the toluene means this is the second place. This number 1, carbon atom number 1, carbon atom 2. So 2-methoxy toluene. And this would be, this is 1, 2, 3, 4. So 4-methoxy toluene. Both these compounds are being formed. So as usual, for anisole, the para position product that is being formed will always be the major product. In the case of Friedel-Crafts acylation, we are going to treat anisole along with acetyl chloride in the presence of catalyst anhydrous aluminum chloride. So here you will find the hydrogen and the chlorine group either from the ortho position or from the para position gets removed and resulting in the formation of ortho product or the para product. You call this as acetophenone. So this is called acetophenone, and so this is methoxy group. So 2-methoxy acetophenone, or this would be 4-methoxy acetophenone. And what are the uses of ethers? They are being used diethyl ether. How do I write down diethyl ether? C2H5O C2H5 is called as diethyl ether. This is used as a surgical anesthetic agent in surgeries, and it is a good solvent for organic reactions and in extractions. It is also used as a volatile starting fluid, and diethyl ether can also be used as a refrigerant. And what are the uses of anisole? Anisole